Hi, today we're going to see the project Deep Learning Based Diagnosis of Skin Vitamin Deficiencies, a comparative study of CNN and DenseNet201 models. The abstract of our project. This project aims to integrate the deep learning models into the healthcare, where the skin condition or the skin diseases or deficiencies can be streamlined with the AI models. This system utilizes the Vitamin Deficiency Image Dataset, which has various classes and the skin disorders, which will be further studied by the two deep learning models, the CNN and the DenseNet, and the comparison between them. The performance comparison between them will make one of the model in use in further in our project. So here we're gonna see the objective of our project. The objective of our project is using the AI for the diagnostic system that processes the classification images. Basically, in our objectives, we will be building an AI-based diagnosis system which can classify the skin disorder images. We will be building two deep learning models using this dataset, the image dataset of skin disorders, and the true deep learning model will be trained and used for the prediction. And in final, the built model will be integrated with an web application so that it can be accessible to the public. And by uploading the images of their skin disorder, they can receive their predictions. The existing system. In existing systems, there are many medical tests available in the market, such as blood test, clinical examinations, and etc. Some image-based AI solutions are also there, but they are limited in scope. They are personalized recommendation, and they often lack in accuracy also. The problem statement is the manual detection of the skin diseases are often time consuming or prone to errors, leading to some potential distraction. But in rising of the skin condition globally, need and permanent early stage of diagnosis. So there is a need of automation and accurate and efficient diagnostic system. So this project aims to leverage the deep learning model, the two model that we have seen, the CNN and the DenseNet, which will be improved in the accuracy, which will be speed enough and accessible enough, and overcoming the existing ones. So here, the methodology of our project is, this methodology has 5 phases. The data pre-processing. Here the dataset image will be taken and pre-processed, such as resizing, normalizing, and removing and replacing the corrupted samples. The data augmentation. This is the phase where the dataset images are flipped, rotated, or zoomed in order to get the different view while model training. And the next is feature extraction. Once the dataset is ready, the feature extraction takes place by the models, by the deep learning models, which extracts the features from the dataset given. And the model training part comes where the deep learning models are optimized and are put to the dataset. The dataset is given to the model and start training and repeatedly fine-tuned. The last phase is the model evaluation, where the trained models are tested with the several evaluation matrices such as accuracy, precision, recall, F1 score, and confusion matrix. This is the proposed system architecture. These are the steps that follows whatever we have discussed over here. As you can see, at the right side of the architecture diagram, we have the web interface. At the left side of the architecture diagram, we have the methodology diagram. The evaluation matrix of CNN. As you can see here, the confusion matrix of CNN, this diagonal colors, which has the dark color, which indicates that the image has classified the disease or the testing set into correct way, but the rest of these boxes, these are the misclassification. Even these are the classification, as there are few large numbers that it has been classified with, and these are the classes names. This is the classification report. As you can see that it achieved an about 72% of accuracy in classifying the classes. Whereas coming to the DenseNet 201, we have the confusion matrix which it predicted correctly, but rest are misclassified, which are very much minimal. If you come to the classification report, you can see that it achieved about 90% of accuracy. So that we can conclude now that the CNN model and the DenseNet 201 model were trained for the classification, but the CNN model achieved only 72% of accuracy, whereas which we can say, yeah, it's in 72% of accuracy, while DenseNet performed about 90%, approximately 90% of accuracy. So here we come with a conclusion that DenseNet 201 can be used for our further process. Now, as you can see this is the base paper that we have followed. This is the base paper that we are referring with, which says vitamin deficiency detection using neural networks. And this is the Jupyter notebook code where the dataset is being taken, where there are 5 classes, as you can see here, the 5 classes, and those are balanced and those are pre-processed, which means resizing, normalization, augmentation, and etc. After that, it is given to the model, and the models are being trained. Those models, after training, are getting this much of accuracies. CNN getting the 72% of accuracy, and DenseNet 201 is getting about 90% of accuracy. Coming to the front end part, as you can see this, once you start your application by saying python app.py, you will be getting an address. On click of this, you will be redirected to this page where you can log in. If you log in with the credentials, you will be seeing this landing page where it is landing on the prediction tab. As you can see here, the graphs for CNN and the DenseNet 201. Okay, if you come to this Vita info tab, you will be seeing some vitamin deficiency informations. And the next is the password tab where you can change the password of yours. And finally, you can log out. But coming back to the prediction tab, here you can give your image samples that you have on your skin and get predicted. Let me try one. Let me check one of this. And say upload. After the processing, it gives the class that it belongs to and at what probability the model is saying that it belongs to this class. It says 100%. Therefore, as you can see here, some of the tips it has been given. So this is how you're going to upload your images that you have in your skin disorder. You will be getting your outputs. Let me try one more image to give. As you can see here, hair loss and alopecia. This image belongs to this category of skin disorder, and the model is sure with 100%. Okay. Finally, you can log out. This is how your project works. So